All right. Hi, guys. So we are doing Geometry Online. So welcome to day one of e-learning. And today we're doing Pythagorean theorem. So I miss seeing you guys, and I hope that you're doing well. And I hope that today's lesson is something that you've already done and something that you've already seen before, and hopefully not something too crazy to learn from a distance. So what you need to do is to get on Schoology and to open the folder that's either called Chapter 8 or Chapter 8.1 and find the notes for this. And as I go through it, I need you to follow along, take notes along with me as we do during class. And then when you're finished, there's a homework that goes with it. And so it's just like normal class, just we're doing it from a distance. So this should look really familiar to what we normally do. And yeah, so it should be familiar. So let's get started. Again, we're doing Pythagorean theorem today, and I hope this is something that you've seen before. So Pythagorean theorem only exists in a right triangle. And what it says is the sum of the squares. Okay, guys, you got to be really patient with me. This is a new app. I really am not sure what's happening, but I'm trying my best. So I appreciate you, and I appreciate your patience. So, okay, it's in a right triangle, and the sum of the squares of each leg equals the square of the hypotenuse. Remember, the hypotenuse is the side across from the right angle, and so we always label that C. The other two sides, A and B, it does not matter which one is which. They are interchangeable. They're just the legs. And so as long as you recognize that C is a hypotenuse, then it does not matter which the other two sides are. And so as we remember, Pythagorean theorem is simply A squared plus B squared equals C squared. All right. All right, so we're going to start by doing an example. So you see this triangle right here, already labeled. First thing we need to do is identify what the hypotenuse is. So the hypotenuse is the side across from the right angle, so that makes that X be your C, and then 9 and 12 are your A and B. Again, it does not matter which one you call which, as long as you know those are A and B and not C. So once we have those pieces, we're going to plug it into our formula. A squared plus B squared equals C squared. So I'm going to write 9 squared plus 12 squared equals X squared. And as you see, we have all these squares, and it's perfect because last week we practiced radicals. So love how this all ties in together. So now we just start solving. 9 squared is 81, 12 squared is 144. Add those together. I have to do my own mental math. I don't have you guys to rely on, so 81 plus 144 is 225. 225 equals X squared. And then now that we're here, to get X by itself, we need to square root both sides. And luckily, 225 is a perfect square root. It is 15. And my answer is 15. Now, bonus question. Should there be a plus or minus in the front of my 15? The answer is no. Since we're in a triangle, I have to have a positive value. There's no way that I could have this side be negative 15. That doesn't make sense, not going to be a thing. So I have to erase this plus or minus. Ooh, yikes. Okay, let me just start all of that over. Erase my plus or minus, and my final answer is just X equals 15. Cool? All right, next part. Got a couple more examples here. Next one says, solve for X, express your answer in a simplified radical. So are decimals okay? No. Got to be in a radical. Again, I start by labeling, so I first find where my C is, so C is across from my right angle. The other two sides don't really matter, and then I set up my equation to solve. So I have X squared plus 7 squared equals 9 squared. Start solving. X squared plus 49 equals 81. I am so sorry for how messy this is. I promise I'm trying. Plus 49 equals 81. You got a minus 49 from both sides. X squared equals 32. We got to do radical of both sides. And so if you are not sure, we're going to need to do our radical of 32 off to the side. I don't think yep, can't zoom. Okay. So I'll do it over here. 32, I'll make a little tree diagram. I've got 4 and 8, and 4 breaks down to be 2 and 2, and 8 becomes 2 and 2 and 2. So I've got one pair of 2s, I've got 2 pairs of 2s, and I've got 1 2 left over. So that makes my final answer be x equals 4 radical 2. Okay. All right, next problem. It says solve for the variables. Express your final answer as a simplified radical. Now this kind of looks like our heartbeat theorem and Nike swooshes that we were doing last week, but now that we're learning about Pythagorean theorem, we're allowed to do this in, I think, an easier way. If we want to figure out what x is, we can do Pythagorean theorem. We know that this is also a right angle because we have supplementary angles down there at the bottom. We know that C is the side across from the right angle, so that makes 10C, and then 6 and x, just A and B. So let's first find out what x is, and then maybe that will help me find y in a second. So I'm going to do 6 squared plus x squared. Like I said, I swear I'm trying to be neat. 6 squared plus x squared equals 10 squared. So I've got 36 plus x squared equals 100 minus 36 from both sides, and I get x squared equals 64. Square root both sides, and that gives me x equals 8. All right, cool. Okay, if I want to figure out what y is, I need to focus on this part of the diagram right here, this little triangle right here. We know that we have 6. I know that I have y. How do I figure out what this distance right here is? Well, if we know the entire distance is 12 and then b is 8, we can do 12 minus 8, which gives us 4. And so this little part of that triangle is 4. So now if I were to redraw my triangle off to the side, I have 6, 4, and then y. My C here is y, my A and B are 6 and 4, so I'm going to do my own Pythagorean theorem right here. 4 squared plus 6 squared equals y squared. 4 squared is 16, 6 squared is 36, and y squared is just y squared. Let's simplify that left-hand side. 16 plus 36 is 52 equals y squared. Ooh, that's not a nice, pretty radical, so we're going to have to do our tree table off to the side. 52. Well, what goes into 52? I thought of 2 and 26 first, and I know 26 breaks down to 2 and 13. So y becomes, got a pair of 2s, so 2 radical 13. All right, not so bad. At this point, if you have questions, pause and either email or find your teacher on Google Chat, Google Hangout, Google Meet, whatever it's called. So if ever you have questions, don't be afraid to ask. Okay, moving on. To determine whether a triangle can be formed by 3 segments, we use the triangle inequality theorem. That states that 2 shorter sides are greater than the longer side. So that states that the sum of the 2 shorter sides, sum of 2 shorter sides is greater than the long side. I don't know if you guys remember, but when we learned this, I pulled like 3 different pencils or just pieces of straight items like a ruler, and I tried to show you whether you could make a triangle or not. And then we had this little formula that said A plus B has to be greater than C. So the two small sides together are greater than C. Okay, so let's remind ourselves about that and do a couple example problems. So if I look down to example A, can these make a triangle? You don't get to just pick the first two and call it a day. You have to pick the two smaller ones, so 5 and 6 are smaller. So is 5 plus 6 greater than 11? I do a little question mark because I don't know if that's true yet. And then I do my math out, and 11 is not greater than 11. So I have to cross that out, and therefore there is no triangle. The next one is 13, 5, and 17. So again, I have to pick the two smaller ones, 15 or 5 and 7. Did I say that wrong? 13, 5, and 7. So 5 plus 7 is greater than 13. Again, we don't know that. Sorry, that's a really ugly 3. 12 is greater than 13. Is that true? No, that is not. Yep, that is not true, so that is not a triangle. Okay, so you should be at the end of your first page of notes. Flip over to the back. Okay, now we're doing the converse of the Pythagorean theorem. So remember, converse is where we switch our thumbs. So the then becomes the if. So I'm doing it at home, but obviously you can't see me. So now we're going to talk about the converse of the Pythagorean theorem. So we're starting with the then. If the squares of the length of the hypotenuse, that says hypotenuse, I promise, is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So essentially, if Pythagorean theorem is true, then it's a right triangle. So if we look at this picture right here, it's saying that if c squared is equal to a squared plus b squared, then that triangle is a right triangle. However, not all triangles are right triangles. So if it's not a right triangle, then we can decide if it's acute or obtuse by using the side lengths. If c squared is less than a squared plus b squared, then the triangle is acute. I like to think of less than and acute go together. So then vice versa, if c squared is greater than a squared plus b squared, then the triangle is obtuse. Okay? We'll come back to that. We'll do a couple examples on this. So now we have an example. Tell whether the triangle is a right triangle. Show calculations. So don't just write right or not right. You got to show me why. We have to figure out which is the longest side. So if you don't know what 6 radical 5 is, throw in your calculator. 6 radical 5 is approximately, you got to give me 1 second. So 6 radical 5 is approximately 13.4. So that helps us decide what's my C. Well, my C is the longest side. So if there was a right angle, it would be in that bottom corner. And so we need to see, is C squared, 6 radical 5, greater than, less than, or equal to 6 squared plus 12 squared. Oop, I forgot my squared. There we go. Remember when we square radicals and numbers in front of radicals, you have to square the 6 and you have to square the radical 5. 6 squared becomes 36, and radical 5 squared becomes normal 5. That's equal to 36 plus 144, and then 36 times 5 is 180, and 36 plus 144 is also 180. How fun. So then that means, since they are equal to each other, then we do have a right triangle. Show calculations. Yep, I showed all my work right here. And then I was able to prove, based on the picture, based on our converse to the Pythagorean theorem, that this is a right triangle. Okay, the last 4 examples that we have to do says decide whether the set of numbers can represent the sides of a triangle, and if it does, then we're going to classify the triangle as right, obtuse, or acute. So first thing we have to do is see if A plus B is greater than C, And if that's true, then we have to do Pythagorean theorem. And I like to do c squared equals a squared plus b squared, because if you think of things in terms of c squared, I think it's easier to decide whether it's acute or obtuse based on our converse that we have on the other page. So I'm going to look at this first example, and I'm going to do, okay, what's 6 plus 9? Is that greater than 10? Well, 6 plus 9 is 15, so indeed that is greater than 10, so I'm good to keep going. Now I got to do my Pythagorean theorem, so I'm going to do 10 squared is equal to 6 squared plus 9 squared. 10 squared is 100, 6 squared is 36, 9 squared is 81, 36 plus 81 is 117. 100 versus 117. 117 is greater, 100 is less than. So c squared is less than a squared plus b squared, and then the less than means acute. All right. Now that we've done one example, I would probably pause this and try the other three on your own and then kind of join in to see if you're doing it right. I'm going to keep going though, so if you're not really sure what's going on, keep following along with me, but if you're feeling good, I would pause this and check yourself before you keep going. All right, I'm going to go C because I like to go just down the list, so I'm going to do 2 plus 2 is greater than 5. 2 plus 2 is 4. That is not greater than 5. Not true, not a triangle. I don't even have to check to see if it's acute, obtuse, or right because it's just not a triangle. Next. All right, now you have 8, 18, and 24. So I'm going to do 8 plus 18 is greater than 24. 8 plus 18 is equal to 26, and that is greater than 24. So that is a triangle. Okay, so that means now we have to check and see c squared is either equal to or greater than or less than a squared plus b squared. So I'll do 24 squared is equal to 8 squared plus 18 squared. 24 squared is 576. Okay. 8 squared is 64, and 18 squared is 324. Oh no. Okay. Add that to 64, and that is 388. So 576 is what to 388? Well, that is bigger than 388. And when c squared is bigger than a squared plus b squared, then we get to call this an obtuse triangle. All right. Now we're on to our last step. Last one. 6 plus 7 is greater than, oh, I actually don't know if root 13 is the biggest one. Let's check what root 13 is. Root 13 is about, oh, I did not mean to do that. Root 13 is approximately 3.6. Okay, good thing I checked because that is the smallest side. So 3.6 plus 6 is greater than 7. That's true because that's about 9.6, which is greater than 7. Okay. I'm also glad I checked because now when I set up my Pythagorean theorem, 7 is your C. And then 6 and root 13 are your A and B, whichever order makes you happy. So I'm going to do 7 squared equals radical 13 squared plus 6 squared. 49 equals 13 plus 36. Remember, when you square a radical, it's an inverse operation, so they get rid of each other. So square of a square root is just its number underneath. So I've got 13 plus 36. 13 plus 36 is equal to 49. Okay, cool. 49 is equal to 49. That is a true statement, so I'm allowed to call this a right triangle. All right, I think we're done with our notes. Make sure that you have this filled in. Feel free to go back and rewatch anything that you're not sure about. And then the homework is on Schoology, so check that out and let us know if you have any questions. Have a good rest of your day. Bye.